This is another video on mathematics for senior 5 accounting. So following generalities on matrices. So here we will talk about matrix definition. It is denoted 111 matrix definition. So we talk about, we see some example of matrix, then matrix notation. So here we will also talk about the size and the order of matrix, especially for square matrices. Okay, so let us start with definition. So there may be many definitions of matrices, but the most common is just a rectangle of data arranged in rows, and in columns. Now, here a matrix is a rectangular arrangement of some mathematical object such as numbers, so into rows and columns, making a table of rows and columns of some mathematical objects, especially numbers in our case. So each number is the entry element or coefficient. When the number of rows is exactly equal to the number of columns, the corresponding matrix is termed as a square matrix. Otherwise, the matrix is a rectangular matrix. In case, of course, a number of rows is not equal to number of columns. Now, every matrix being a square matrix or rectangular matrix, every matrix can be written in square or round bracket. So, example, two matrices, let us say A and B. So A as the first row, second row, first column, second column. Here matrix B, first row, second row, first column, second column, third column. So they can be written in either in bracket, round bracket, or as you have said, in square bracket, square here. These are square brackets, a pair of square brackets or round brackets. So notation of matrix, which will give an idea of how. So it is a shorthand notation of these brackets. We can make it shorter. So it informs you about the size and the order of a matrix. What is order? Size of a matrix. So from the notation, so every matrix, say A, can be written in notation by using its coefficients like A, I, J. So where I, the first subscript, I indicates the row at which the coefficient is located, and the second subscript J indicates the column where the coefficient is located. Now, for example, a 2 by 2 matrix, which means has got 2 rows and 2 column matrix. So it can be written as A11, A12, making the first row, A21, A22, making the second row. So the first number here indicates the row. So these two coefficients are at the first row, which is indicated here. So these ones, A21, A22, it is just a row made of these two coefficients, and they are at the second row. So the first index, the first subscript is indicating the row at which the coefficient or the entry or the element is located. So now, how about the second subscript or second index? So let us start by this one, 1 and 1 here. So the second index indicates the column in which the element or the entry or coefficients is located. So like these are ones, J1. So it indicates that A11 and A21, it makes the first column. And these are 2, so it makes the second column. So this matrix B, so it has 2 rows, the first row, the second row. So it has 3 columns indicated by this subscript here: first row, second column, first column, second column, third column. So which means that this B13, B23 is the third column elements or coefficients, and this one B12, B22 second column, and B11, B21 first column. So B is the matrix B is made up of 1, 2, 3 columns. Now, here about this first row. So this one, let me use another marker pen here and here. So this one makes the first row. Which means that coefficient B11, B12, B13, it makes the first row. First column, second row is this one, because we have 2, 2, 2 indicating second row. So in particular, a matrix of one column is like this one, 1, -2, 0, is a column matrix. And when it has only one row, like B made up of 0, 0, 1, so it is just one row. In that case, it is a row matrix. Now, how about the number of rows and number of columns of a matrix? The product of them is a number which is called the size of the given matrix. So, for example, here we have the size of matrix B is 2 times 2 times 3, because we have 2 rows and 3 columns, and then its size is said to be 2 by 3 matrix. And this matrix, this is A square matrix. It is made of 2 rows and 2 columns. That's why it is called a 2 by 2 matrix, and its size is just 2 rows times 2 columns. Now, when the number of rows is equal to number of columns, in this case columns, in this case we say that the matrix it has order n or m because they are, in this case, they are equal. So, for example, so as a counter example, this is not a square matrix. So normally we, instead of talking about its order, we may talk about its size. But sometimes people may take order for size. But in particular, square matrix has order. For example, this one, because square matrix is 2 rows, 2 columns, it has the order 2. So this one has size 2 times 3, which makes it 6 actually. So uh, now about the notation. For example, if you have a matrix, this is square matrix, at the first row, first column, we have number 1, and so on. So now here we have a question. What is the order of this matrix? Considering what we have been talking about. Now, write down the values of 2 coefficients, A23 and A31, if you have this matrix. Now, this is what we are going to talk about now. And after that, we have an activity to be done. Okay, now let us have this space right here. We are going to look for to answer these 2 questions. Question A: what is the order of this matrix? Number B: we're gonna be finding the coefficient A23 and A31. So with this is sign of equality. So we're gonna talk about later on. We will make a video on this sign of equality, what it really means. But for the moment, let us, we know in general what equality sign says about 2 quantities to be equal. But for matrices, it is a very profound, it has a very profound meaning when it comes to equality. But for the moment, let us answer these 2 questions before we move to applications. So now, so we're gonna first answer these 2 questions. So answer to this question A. Now, what is order of this matrix? So this is a square matrix, which means that the order is number of rows as well as number of columns, because they are both equal. Number of rows is 3, number of columns is 3, which means that the order of this matrix, here is the matrix, it is actually A, so which is equal to 1, 3, 4, 5, 12, 13, and 7, 6, 0. So we have this situation, and we see that in this case, excuse me, in this case, so first row, second row, third row, so three rows, first column, second column, third column, 3 columns. Okay, this is So the size of this matrix is just 3 by okay 3 by 3, or sometimes we may write 3 times 3. Okay, this is the size. How about the order? The order is just 3 because we have 3 rows as well as 3 columns. So the order is 3. So now, because this is a square matrix, so the size, so, the size of this matrix, so it is 9, which is 3 by 3. Actually, 3 times 3 is 9. Is 9. 3 times 3. Size of this matrix is 9 as size. It is better to indicate the number of rows and the number of columns. Okay, now moving on to question B. So question B. So in this example, so what are coefficients 8, 2, 3 for this matrix? And what are I'm gonna find the answer. What are the coefficient A, 3, 1 in this case? So what is it? Okay, so now so for this matrix, so it is first at the first row, first column, first row, second column, first row, third column. This element, second row, first column, second row, second column, second row, third column. This coefficient is and the intersection of third row, first column, third row, second column, third row, third column. So this is this matrix. Now the coefficients of this matrix are these. So now we are asked to find the coefficient A23. A23. So this is at intersection. The coefficient which is located at intersection of second row or row 2, and column 3, column 3, or third column or column 3, same. Row 2 or row second row, same. Now in this case, this element, it is now at this intersection. So we can see it is 13. So in that case, we have 13. Okay, now what is the coefficient which is located at the third row, first column? So once again, so let me use a different color. So in this case, A3, we are at the row number 3, row 3. So first column, column 1, first column, or column 1, third row or row 3. Same. Now, in this case, we're looking at coefficient which is at this intersection, and this is no, here I'm mistaken. It is not this one, but an intersection is here. Okay, A3, A31. So it is going to be 7. So here we have A31 is 7. Okay, now let us move to application activity. So let us talk about application activity. So this activity is denoted 111 in the syllabus of senior mathematics for senior 5 accounting. We talked about in the previous video. So let us look at how this activity is structured. So we have 2 questions. So the first question is, let me just write the first question. So number one, okay, maybe in the video this part is not maybe visible. So this is column 1. Column 1, first column. Okay, now let us now move to the yes. Okay, let us now move to the application activity. So the activity is telling us to write down the order or size. So size is more general than order of each of the following matrices. So number 1, number A. So question A is the matrix A, 8, -1, first column, second column, 6, 1, third column, 2, 0. Okay. Number B, okay. Second matrix. Let me just use this eraser. Number B. So we have second matrix is B. It is a row matrix. -2, 1, 3. So now we have number C. So question C is matrix C, which is a column matrix because it is made up of one matrix. Okay, so that is number 1 question. Number 2 question is this. So I'm writing down a shoe shop. Sells shoes for men and ladies. For men and ladies. Now the first week it sold this shoe shop. It sold 7 pairs of men's shoes. And 15 pairs of ladies' shoes. shoes. Now, the second week, the shoe shop sold 9 pairs of ladies shoes, and they also sold 4 pairs of men's shoes. Okay, now the question is, record this information. You have to record this information as a 2 by 2 matrix by stating what the rows stand for, and by stating what the columns stand for. Okay, now this application activity. Now let us now try. If you are watching this video, you can just pause the video and try to do these 2 questions in order to carry out this activity 1 on 1. Okay. Okay, so now let us now, in this case, let us try to start by number 1, answer to activity 1. So let us answer. Maybe can use a different marker pen. This. So let us answer to application activity 1. Okay, so number 1, let us work out number 1 and try to find out what is the answer for question A, sub-question B, sub-question C. Okay, so Now, let us look at the answers for these activities. Okay, write down the size. So sometimes not to be confused with the order of each of the following matrices. So the first matrix A is a 2 rows, 3 columns. This is 2 by 3 matrix, 3 columns, 2 rows. Okay. So sometimes we can write it as 2 times 3, which is actually 6. Okay, that is the size of this matrix. So here we have the order of the size, not the order, size of matrix A is 2 times 3. Second matrix, so we have 1 row, 1, 2, 3 column. So in this case, we have a 1 by 3, or just 1 times 3. So in this case, the size of B is 1 times 3, or 1 by 3. So sub question C, this one is a column matrix. We have 1, 2 rows and 1 column. This is the 2 by 1, or just 2 times 1. So the size of C, matrix C, this is column matrix, is 2 times 1, 2 by 1. Okay, that is for question 1. So question 2. Question 2. So we have this question. So a shoe shop sells shoes for men and ladies. The first week, it sold 7 pairs of men's shoes and 15 pairs of ladies' shoes. The second week, it sold 9 pairs of ladies' shoes and 4 pairs of men's shoes. Now we have to form a matrix combining these information. So in order to do so, we have some to name, some definition, abbreviation, so that you have a concise result leading to the record of this information as a matrix. We are told that is a 2 by 2 matrix. So why? Because if we denote W1 in the first week, let us call it first week, or we may call it week 1, or simply week 1, like this. Okay, and then W2, let us call it second week, or just week 2. Okay, so now let us now see what has been done by this shoe shop in the first week. It sold 7 pairs of men's shoes and 15 pairs of ladies shoes. Let us call these ones as pairs of men's shoes. Let us call it MS. Let us call it men's shoes. Pairs of men's shoes. Number of pairs of men's shoes. Let us call there are also for men and for ladies. So ladies shoes pairs of, let us call AS, pairs of ladies shoes, for example. Okay, now let us see how we can make this record. Okay, we have two ways. We can make weeks in column, and so pairs of shoes, number of pairs of shoes and column. We have men's shoes and ladies shoes. Okay, so now in this case we are looking for this information like this. So now in the first week, it is also 7 pairs of men's shoes and 15 pairs of ladies shoes. So in the first week, men's shoes were 7 pairs and ladies shoes 15 pairs. Okay. So how about the second week? That was the first week. Week 1. Now week 1 is this one, these results, and so second week, where is it? The second week. So let us call this one second one. So the first one 7 and 15 for the first week with just one line, simple line. So in the second one we have 9 pairs of ladies shoes, 9 pairs of ladies shoes. And what is 4? 4 is number of pairs of men's shoes which are sold in the second week. So we have 4 just right here. So now what we have now here is now the matrix. We have in this case, this is let us call matrix A, call this matrix. So we can write it like first column 7, 15, second column 4, 9. Okay, 4, 9. Okay. So now, but this is not the only way we can solve this problem. So we can put weeks in rows. So like, okay, let me just use this now. Let us put weeks in rows, and then try to find out what will be pairs of men's shoes, pairs of ladies shoes sold. Okay, so now in this case, what we have is in the first week we sold the shoe shop sold in the first week 7 pairs for men, 15 for ladies. 7, 15. So in the second week, they sold 9 pairs for ladies, 9 pairs for ladies, and 4 pairs for men. So this one. Okay. So now the matrix that we have is this one. Both are square matrices, but let us call this matrix B, which first column is 7, 4. So 15, second column 15, 9. 15, 9. Okay. So what we can say there, so this information can be recorded as matrix A or the square matrix B. Both are square. So if you compare these two matrices, so we see that these two matrices are a transpose of each other, of one another. This means that matrix B is just the transpose of matrix A. But both can represent this information in the second second question. Okay, so now this is the end of this video today. So next time we're gonna be talking about equality of matrix, even though we have already started. So we're going to talk about equality of matrices. When do we say that the two matrices are equal? So we will see that there is we will discuss deeply when we have to say that two matrices are equal. Of course, here they are equal because we are talking about so B is this one, this matrix, and this one is transpose of the other, but this one it is B, but B is the transpose of this one. They are not equal. B is different from A, but B is the transpose of matrix A. We are going to talk about when matrices are equal. So of course this one and this one are different. A is different from B. So A is different from B. So as I was saying, we are going to talk about equality of matrix by next time. Okay, thank you for watching.